Good morning. Today we are going to discuss about aromaticity. Myself, K. Ravikumar, Associate Professor, Department of Pharmaceutical Chemistry, School of Pharmacy, Nalla Narasimha Reddy Education Society, Group of Institutions. So, in the topic aromaticity, the main objectives here are the student able to define aromaticity, explain the attributions of aromaticity, the common features of all aromatic compounds, which confers to the aromaticity, define Huckel's rule, that is 4n plus 2 pi electrons, number of electrons which are present in aromatic compounds, analyze the aromatic compounds by Huckel's rule. So these are the topics which we are going to discuss, and student able to define aromaticity, criteria for aromaticity, Huckel's rule, and analyze the aromatic compounds by Huckel's rule. So before going to the topic, the very important point we need to discuss here is there are certain queries, questions, why the benzene is different from other compounds. Why benzene derivatives show different properties as compared to aliphatic compounds. They have different properties. Why that is so? Why benzene undergoes substitution reaction rather than addition reaction and oxidation reaction? Benzene always resists to undergo addition reaction and oxidation reaction, but it undergoes substitution reaction, and benzene shows unusual stability. And by substitution such as chlorine, hydroxy group, NH2, when they are directly attached to the aromatic nucleus, they act as electron donating group, but when they are attached to the aliphatic compounds, they're acting as electron withdrawing group. So what is different here? Why these aromatic compounds are different from aliphatic compounds? So these questions can be answered when we discuss about aromaticity. So by the definition, to know the aromaticity of different compounds, there are 4 criteria that a molecule should satisfy. The properties that should satisfy are: the molecule should be cyclic, the molecule should be planar, and completely conjugation means alternate double bonds should be there in its nucleus, and it should satisfy Huckel's rule, that is 4n plus 2 pi electrons should be there in the molecule. If a molecule, a compound is satisfying these 4 criteria, that is cyclic, planar, complete conjugation, and Huckel's rule, then the molecule can be said as aromatic. If any one of these criteria is not there, then it may not be called as aromatic, it is non-aromatic. So we'll see individually what are the individual criteria for satisfying the aromatic property. So coming to the first criteria, that is a molecule should be cyclic. A molecule should be cyclic means, if you take the example of benzene, benzene is a cyclic molecule, and why this molecule should be cyclic? Because to overlap, each carbon is having a p orbital that should overlap. When they are overlapping each other, then there is a delocalization of electrons takes place. So always a molecule should be cyclic in nature to get an aromatic property. If it is alicyclic compound, then their aromatic properties may not be take place because there is no delocalization. If I have an example, that is 1,3,5 hexatriene, so it looks similar to that of benzene structure, but it is not cyclic molecule, where the 3 alternate double bonds are there, but the first carbon and last carbon p orbital, they are not interacting each other. When they are not interacting each other, there is no formation of molecular orbital form. So this is a alicyclic compound. Sometimes the p orbital may come together, sometimes the p orbital may go away from each other. So the overlapping of these 2 p orbitals will be very tough such that this molecule is not aromatic in nature, but the structural similarity is there. Alternate double bond and 6 number of carbons are there. But this 1, 3, 5 hexatriene is not a aromatic compound, whereas benzene is a aromatic compound. Why? Because it is a cyclic molecule and there is a interaction of p orbitals effectively. So to be aromatic, each p orbital must overlap with the other p orbital which are adjacent to each other. So this 1, 3, 5 hexatriene is not aromatic in nature. And next point, next criteria, that is a molecule should be planar. What do you understand about planar? Means it should be straight. It should be a planar structure. Means the carbons should be in one plane. So all the adjacent p orbitals must be aligned straight. Must be aligned. What does it mean? Means the p orbital should be always perpendicular to the plane of the structure, so that the electron density, the electron pair can overlap or delocalize from one carbon to the other carbon. So in any cyclic molecule, the p orbitals which are perpendicular to the plane of the structure, they should be aligned, means they should be straight, such that the overlapping will be easy. So the p orbital must overlap continuously around the ring such that they can form a delocalization of electrons. The shifting of electrons from one carbon to other carbon takes place, so electron cloud is formed. If they are not planar, then they may not be called as aromatic. So we have an example, that is cyclooctatetraene. Cyclooxatetraene means it is a cyclic compound which contain tetra bonds, but 4 double bonds are there, and it is a octatetraene. So if you see this structure, it looks like aromatic compound because all the carbons are having p orbital, which looks like they are perpendicular to the plane of the structure, but this is not aromatic. Why this is not aromatic? Because though it is a cyclic structure, though it is looking like a planar structure, though it is having other properties, but it is not aromatic. Why? Because if the p orbitals are perpendicular to the plane of the structure, then this structure is more strained. Because when the molecule is strained, it has tendency to come out of the plane structure, so it forms a tub-like structure. When it forms a tub-like structure, the p orbitals are not aligned. When they are not aligned, they look like the p orbitals will be in disorganized manner. So when the p orbitals are disorganized manner, means they are not in the aligned form and they are not straight, they cannot overlap each other to form the delocalization. So the adjacent p orbitals cannot overlap because they are not aligned, they are not straight. So that is the reason they cannot delocalize the lone pair of electrons from one p orbital to other p orbital. So this cyclooctatetraene is not aromatic. Why? Because the p orbitals are not aligned. So when they are not aligned, they are not planar. So cyclooctatetraene is not planar. That is the reason they are not aromatic. But whereas benzene, see, all the p orbitals are in the plane. When they are in the plane, they can overlap each other effectively, continuously, and form the ring. So benzene is aromatic in nature, but octatetraene, the cyclooctatetraene, because it is a tub-shaped molecule, so it is not planar and it is not aromatic. When you come to the third point criteria, the molecule should be completely conjugated. What does it mean? Completely conjugated means there should be alternate double bonds, complete alternate double bonds. When you get alternate double bonds, when you have p orbital on each carbon, when you have p orbital on each carbon, so there is a possibility of complete conjugation. So if you see this benzene ring is a closed circuit with 6 carbons. Each carbon is having one p orbital. Each carbon is having one p orbital. The p orbital will overlap with neighboring p orbital to form a pi bond. So 6 p orbitals overlap each other to form 3 pi bonds. So it is a continuous conjugation. So benzene is aromatic in nature, but whereas these compounds, there are certain compounds which are not conjugated. If you take one example, that is 1,3 cyclohexadiene. It is two double bonds are alternate to each other, but the next two carbons, they are not having double bond. Means these two carbons are undergoing sp3 hybridization. When they are having sp3 hybridization, they have tetrahedral structure. So this sp2 hybridized carbon will be having planar structure, and sp3 hybridized carbon will be having a tetrahedral structure. So this molecule is out of conjugate, out of planar structure, and they are not conjugated. Means these two carbons are not having p orbitals. When they are not having p orbitals, they cannot overlap with this pi system. So when there is no delocalization or resonance transfer, electron transfer, then there is no delocalization takes place. So complete conjugation is not taking place. That is the reason 1,3 cyclohexadiene is not aromatic in nature. So other compound, so if you see 1,3,5 cycloheptatriene, if you see, this looks like aromatic in nature because it is having a complete aromatic conjugation. Complete, it is having a alternate double bond, single bond, double bond, single bond, and double bond. So it is having alternate double bonds, but this carbon is not in conjugation with the pi system because it is a sp3 hybridized carbon. When this is a sp3 hybridized carbon, the pi electrons from this carbon or this carbon are not delocalized to this carbon because it is not having a p orbital. So 1,3,5 cycloheptatriene, though it is cyclic, though it is having conjugation, but it is not complete because one carbon is denying, it is not having p orbital. So delocalization is not possible here. So when delocalization is not possible, so complete conjugation is not possible. So that is the reason it is not aromatic in nature. The fourth point we need to concentrate, that is molecule must satisfy Huckel's rule. So what do you mean by Huckel's rule? So it should contain a particular number of pi electrons. Any system, any cyclic system, it should have a particular number of pi electrons. P orbital containing one electron should be there. Why? Because when the particular number of pi electrons are there, then there is a possibility of delocalization. If it contains more, if it contains less, there is a possibility of not delocalization takes place. So if you see, any aromatic compound must contain a particular number of pi electrons, that is 4n plus 2 pi electrons. So any compound, any aromatic compound, a cyclic compound, if it contains 4n plus 2 pi electrons, then it can be called as aromatic. So if n is giving an integer value, if n is giving an integer value such as 0, 1, 2, 3, 4, 5, then the molecule can be called as aromatic in nature. So we'll have an example, benzene. Benzene is said to be aromatic compound. Why benzene is said to be aromatic compound? Because it is a cyclic compound, it is planar. Why it is planar? It is having sp2 hybridized carbon, so it is a planar trigonal. So benzene is cyclic, benzene is planar, and benzene is having complete conjugation. And also last point, it is satisfying, that is benzene is satisfying with particular number of pi electrons, that is 6. Benzene is aromatic in nature, especially stable because it contains 6 pi electrons. Why? How 6 pi electrons? Because each double bond comprises of 2 pi electrons. 2 pi electrons, 1 pi electron here, 1 pi electron here, 1 pi electron here, such that 3 double bonds are there and 6 pi electrons are there. So benzene is having 6 pi electrons. We'll see when you apply this 4n plus 2 pi electrons here, then it should contain, the n should be integer. We'll see when you apply the 4n plus 2 pi electrons, so total number of electrons in benzene is 6 pi electrons. So 4n plus 2 is equal to 6 pi electrons. So 4n is equal to, when you shift this 2 to right side, 6 minus 2 is equal to 4. 4n is equal to 4, n is equal to 4 by 4. Then it leads to 1. So 1 is an integer. So when integer 1 is there, then the molecule can be aromatic. Means if a system is having 6 pi electrons, then the molecule can be called as aromatic, providing it should satisfy other criteria also, that is cyclic, planar, conjugation, and also 6 pi electrons. So we'll see other system, that is cyclobutadiene. When you see the structure of cyclobutadiene, It is a 4-member cyclic structure which is having two pi bonds. When it is having two pi bonds, means it is having how many pi electrons? One pi electron here, one pi electron here, and another pi electron here, and another pi electron here. Total 4 pi electrons are there. So cyclobutadiene is anti-aromatic. Why? Because it is unstable. Why it is unstable? Though it is carbon is undergoing sp2 hybridization, the sp2 hybridized carbon should have a 120 bond angle, but it is having a 90 degrees. So it is in the strain. The cyclobutane is in the strain. So it is, though it is a planar structure, so it is having less number of pi electrons. That is 4 pi electrons are there. So when we apply the Huckel's rule with this, so 4n plus 2 pi electrons, 4n plus 2 is equal to total number of electrons in cyclobutadiene is 4 electrons. So when 2 comes to the right, 4 minus 2 is equal to 4, n is equal to 2 electrons. So n is equal to 2 by 4, it is coming as a 0.5. So it is not coming as a integer. When it is not coming, n is equal to integer, so it cannot be called as aromatic. So it is coming as fraction. So fraction, n is equal to fraction does not give the aromatic properties. Instead, so this it is a anti-aromatic molecule because it is having 4n pi electrons. 4n pi electrons. So if you see here, anti-aromatic definition, that is cyclic molecule, it is a planar and completely conjugation compounds that contain 4n pi electrons. 4n pi electrons means how many electrons are there here? 1, 2, 3, 4. 4 electrons are there. So 4n pi electrons, which is unstable, and it is called as anti-aromatic. So cyclobutadiene is anti-aromatic because it is not having n is equal to integer. It is having a fraction and it is having only 4n pi electrons. So that is the reason it is anti-aromatic. So other examples for aromatic compounds, we called as aromatic compounds, polycyclic aromatic compounds. This structure we called as naphthalene. Naphthalene, when you see how many pi electrons are there in naphthalene, total double bonds, 1, 2, 3, 4, and 5 double bonds are there. When 5 double bonds are there, 5 into 2 pi electrons, it is used as to 10 pi electrons are there in naphthalene structure. So we'll see whether this naphthalene is aromatic in nature or not. So we'll apply this Huckel's rule. 4n plus 2 is equal to pi electron. 4n plus 2 is equal to 10 pi electrons. So 4n is equal to 10 minus 2 is equal to 8 pi electrons. That is n is equal to 8 by 4. It is equal to 2. It is coming integer. Whenever the molecule is cyclic, planar, and complete conjugation, and Huckel's rule is having n is equal to 2 or integer, then the molecule can be called as aromatic. So naphthalene is an aromatic molecule. So when you see other cyclic structure, this molecule is called as anthracene. Anthracene contains how many pi electrons? If you count the double bonds, 1, 2, 3, 4, 5, 6, 7, 7 double bonds are present. So 7 into 2, 14 pi electrons are present in anthracene. So when you apply the Huckel's rule, it is coming n is equal to 3. N is equal to 3 is an integer. So definitely anthracene is also a aromatic compound. So if you summarize, so if we have total number of pi electrons in the system, that is 6, 10, 14, and 18, then the molecule can be called as aromatic. Why? Because when you apply the Huckel's rule, the number integer is n is equal to, we get 1, 2, 3, 4 respectively. If we have 6 electrons, then n is equal to 1. If then we have 10 electrons, n is equal to 2. If we have 14 electrons in a system called as anthracene, we call it as 3, n is equal to 3. So it follows Huckel's rule, and all these molecules, benzene, naphthalene, anthracene, and these are all aromatic in nature. And when we observe the total pi electrons are 4 or 8, then it is coming under anti-aromatic. If a system is having 4 pi electrons like cyclobutane, or 8 electrons like octatetraene, cyclooctatetraene, they are called as anti-aromatic because it is following it is having 4n pi electrons. And if a system is having 12 electrons or 16 electrons, then the molecule can be called as aromatic. Non-aromatic means non-aromatic is nothing but if at all any molecule is having any one of, it is not having any one of four parameters, four criteria, then such molecule is called as non-aromatic. So it is giving the Huckel tool N is giving fractions that is such as 0.5, 1.5, 2.5, and 3.5 respectively. So this may be anti-aromatic or non-aromatic. If you consider simple examples in a single slide, so benzene is having cyclic molecule, it's planar, complete conjugated, and having a pi electron, 4n plus 2 pi electrons, number of electrons are 6, and this is having aromatic properties and having a resonance energy of 36 kilocalories per mole. This is unusual stability is there in benzene. Whereas if you take cyclobutadiene, it is cyclic, it is conjugated, and 4 and pi electrons are there. Though it is flat, it is quietly unstable, and because it is having 4 and pi electrons, and it is non-aromatic, anti-aromatic in nature. And cyclooctatriene, though it is cyclic in nature, it is having complete conjugation, but it is not planar because a stable molecule of octatetraene is tub-like, and it is escaping from anti-aromaticity, and it is non-aromatic. Why it is non-aromatic? Because it is not a planar structure. Though it is cyclic, though it is complete conjugation, and it is having 8 electrons, but it is not planar, so it is non-aromatic in nature. Other compounds are also aromatic in nature, such as aromatic heterocyclic compounds. A heterocyclic compound is a compound having heteroatom in its ring system other than carbon. So if you see this, it is a benzene-like structure, but where carbon is replaced with a nitrogen, so it is heterocyclic compound. It is a pyrrole, and it is 5-member ring with oxygen called as furon, 5-member ring with sulfur we call as thiophene. These are all molecules we can see. These molecules have 6 pi electrons. If a molecule is having cyclic, planar, complete conjugation, and 6 pi electrons, then these molecules can be called as aromatic in nature. We will see individually each compound whether they are aromatic or not. So the heteroatom, sometimes it donates 1 electron to the pi system, or sometimes it donates 2 electrons to the pi system. So if you see pyridine is contributing only 1 electron to the pi system, because pi carbons are contributing pi electrons and nitrogen is having 1 p orbital. Total 6 pi electrons are contributing each other in the pi system to form aromatic system. So 6 pi electrons are there in pyridine. So in pyrrole, only 4 carbon atoms are there. Each carbon atom is having 1 pi electron, and nitrogen is contributing 2 pair of electrons and 2 electrons, such that 4 carbons, 4 electrons, and nitrogen is donating 2 electrons, such that it is contributing 6 electrons in its pi system. Similarly, in furon also, 4 carbons plus 2 electrons from oxygen involved in pi system. In thiophene also, 4 carbons and 2 electrons from sulfur contribute to the pi system. So these heteroatoms, either it may donate 1 electron like pyridine, it may donate 2 electrons like pyrrole, furon, or thiophene to the pi system. So if you come to the pyridine structure, it is a 6-member heterocyclic compound with nitrogen, and pi system resembles like benzene. It contains 6 electrons. The lone pair of electrons which are there, they are not involved in pi system. Why? They are not involved in pi system because see here, it is having, each carbon is having 1 pi electron. So 5 carbons, 5 pi electrons, and nitrogen, which is a p orbital, which is perpendicular to the plane of the structure, they are contributing 2 electrons each, 1 electron each to the carbon, so contribute to the pi system. Whereas the lone pair of electrons, they are away from nitrogen, they are away from the perpendicular system. The orbital is perpendicular to the pi system, and so they are not involved. The lone pair of electrons are not involved in delocalization. So pyridine is aromatic in nature because it is having a cyclic nature. It is completely conjugated, planar structure, and it's satisfying Huckel's rule because it is having 6 pi electron. So pyridine is a aromatic in nature. When you come to pyrrole, pyrrole is a 5-membered structure with 1 nitrogen. The pi system is similar to that of cyclopentadienyl anion. Cyclopentadienyl anion. So when you see here, nitrogen is having two electrons. Nitrogen is undergoing sp2 hybridization, and nitrogen lone pair of electron is involved, is contributed for pi system, because pyrrole is having only 4 carbons. 4 carbons contribute 1 pi electron, so that 4 electrons will be forming 2 double bonds, and nitrogen lone pair of electron is involved in delocalization, so it completely forms 6 pi electrons. 6 pi electrons will be present in the pi system of pyrrole. So this pyrrole is aromatic in nature. So it is aromatic in nature. Furan structure. If you see, one more point here, you have to remember cyclopentadienyl anion. What is a cyclopentadienyl anion? You remove this nitrogen and keep a carbon with a negative charge. So negative charge, carbon 1 pi electron from its carbon and extra negative charge will contribute 2 electrons, and these 4 carbon 4 electrons will contribute pi system. So pyrrole is similar to the of cyclopentadienyl anion. So anions can also be aromatic in nature. For example, cyclopentadienyl anion. So it is similar to the structure of pyrrole, where nitrogen can be replaced with of carbon with negative charge. So furan, which is the 5-member ring system with oxygen. So here furan is having 4 carbons. 4 carbons are contributing 1 pi electron each. So 4 carbons, 4 pi electrons will form 2 double bonds. This system is having 2 pi electrons, and this system is having 2 pi electrons. And oxygen, p orbital contain 2 lone pair of electrons. 1 lone pair of electron will contribute, involved in the pi system, such that 2 electrons from oxygen and 2 double bonds will overlap each other to form a pi bond. So 6 pi electrons are present in the furan. So this will contain 6 pi electrons, and this is aromatic. Similarly, thiophene also contributes similarly as that of furan. So it contains 6 pi electrons. So thiophene and furan, they are aromatic in nature. So other type of compounds which are there in now we call as annullines. Annullines are nothing but cyclic hydrocarbons, long chain cyclic hydrocarbons with single alternate and double alternate single and double bonds. So benzene, for example, we call as 6 annuline. But if we have more number of carbons, more the cyclic compound is having greater than 6 carbons, we give accordingly number of atoms in the bracket, and we call it as annuline. The basic criteria for annuline is it must have cyclic compound which alternate double bond and single bond. They should be planar, such that they can overlap each other to form a pi orbital. So cyclopentadiene is called a 4 annuline, benzene is called 6 annuline because it contains 6 atoms. Cyclobutadiene is called 4 annuline. Cyclooctatetraene is 8 annuline, and cyclooctadecapentyene it is a 10 annuline, because 10 carbons are there, 10 pi systems are there. So these are hydrocarbons which contain single ring compounds which contain alternate double bonds and single bonds, called as annuline. They are completely conjugated. Sometimes there are larger ring structures which contains alternate single bond and double bond, and they are planar in structures, and also they should satisfy Huckel's rule. What is Huckel's rule? 4n plus 2 pi electrons. 4n plus 2 pi electrons. So here we have 2 examples to name annuline. What is the total number of atoms which are there in the ring? We should keep in the bracket and call as annuline. So benzene is called 6 annuline. Here we have one compound, that is 14 annuline. So whether it is satisfying Huckel's rule, we'll see. That is 4n plus 2 is equal to 14 electrons. 4n is equal to 12 electrons. N is equal to 12 by 4 is equal to 3. So this n is contributing 3. It is an integer. So this 14 annuline is a aromatic in nature. And one other example we have, that is 18 annuline. 18 aniline, it is a cyclic molecule planar because it is all the carbons are undergoing sp2 hybridization and there is a chance of delocalization because this bond shifts here and this bond shifts here, this bond shifts here. So there is a delocalization takes place here. So it is it may be aromatic, but we need to check for Huckel's rule. So 4n plus 2 is equal to how many electrons? We have 18 electrons. 4n plus 2 is equal to 18 electrons. So 4n is equal to 16 electrons. N is equal to 16 by 4 is equal to 4. So it is coming integer. N is equal to 4. So definitely 18 aniline is a aromatic compound. Means when you revise all compounds which contain 6 electrons or 10 electrons or 14 electrons and 18 electrons, they are called as aromatic in nature. So but 10 aniline, it is not aromatic in nature. Why? Though it is satisfying Huckel's rule, but it is not planar. Why it is not planar? If you see this structure 10 aniline, the carbon here have one hydrogen and this carbon is having one hydrogen. These two hydrogens overlap each other such that the molecule is more strained. So when the molecule is more strained, the molecule has tendency to come out of the plane. So one hydrogen, this carbon hydrogen moves away from each other, this carbon. So if you see the structure, it forms a plucked structure where hydrogen move far away from each other. So because of that, the structure is not planar. So though it is cyclic in nature, though it is having complete conjugation and it is satisfying Huckel's rule, that is 10 pi electrons, this molecule is not aromatic. Why it is not aromatic? Because it is not planar. Why it is not planar? Because these two hydrogens are overlapping each other. That is the reason it is not forming planar and strained molecule. The molecule has tendency to come out of that strain, so it produces puckered structure. Because of that, two hydrogens move away from each other, so the molecule is not planar. So in this molecule, in this class, we have defined aromaticity. All the molecules are said to be aromatic if they contribute with the 4 different criteria. That is, they should have cyclic molecule, they should be planar structure, means all the atoms should be sp2 hybridized carbon, and complete conjugation should be there, alternate single bond and double bond should be there, and it should satisfy Huckel's rule. So that if at all any molecule is satisfying these 4 properties, then molecule is defined as aromatic in nature. Means the cyclic compound which is planar has a complete conjugation. There is a possibility of delocalization from one carbon to other carbon. That is the reason there is a complete conjugation takes place. Complete electron cloud is formed. Because of that, resonance energy decreases, and that is the reason aromatic compounds are not undergoing a addition reaction, rather it undergoes substitution reaction. Why? Because these properties, that is cyclic, planar and complete conjugation and Huckel's rule, a particular number of pi electrons, that makes a molecule dynamic. Because of the dynamic system, the electrons move around around the cycle and makes a molecule more stable, and it gives rise to substitution reaction rather than addition reaction. So these points are satisfying with that first 4 points what we have discussed, that is different properties rather than aliphatic compounds, and these are undergoing substitution reaction. Then there are addition reactions. The molecules are having different properties. Why? Because if you take example of chlorine when it is attached to ethane, it becomes ethyl chloride. It is acting as chlorine is acting as a withdrawing group. But when the same chlorine is attached to benzene, though it is acting as a deactivating group, but it is donating electrons to the aromatic nucleus. So chlorine is acting as a donating group in aromatic compounds because there is a delocalization of electrons in aromatic compounds. So chlorine is acting as an electron donating group in aromatic compounds. The same chlorine is acting as electron withdrawing group aliphatic. So these two are different. So the same function group is acting differently in aromatic and aliphatic. That is only because of aromaticity. The criteria we have seen, that is cyclic, planar, complete conjugation, and Huckel's rule. we have defined so many examples which compounds are aromatic in nature, which compounds are anti-aromatic, which compounds are non-aromatic. So any aromatic compound which satisfies Huckel's rule 4n plus 2 pi electrons, then the molecule is said to be aromatic. So anti-aromatic, any molecule which is planar, cyclic and complete conjugation, but it is having 4n pi electron, then it is said to be anti-aromatic. And non-aromatic, if at all any of the four properties are not satisfied, then the molecule is said to be non-aromatic. And Huckel's rule, it is 4n plus 2 pi electrons. Then anilines, we have seen cyclic compounds which are having more number of alternate double bonds and single bonds. It may be greater than 6 carbons. Such molecules we call as aniline. 6 carbon, 10 carbon, 10 carbon, and 14 and 18 carbon anilines are aromatic in nature. 10 carbon containing molecule is not aromatic because there is a plucked structure produced in the 10 anilines. So this is about aromaticity, and we have referred Balan Ball and Morrison Boyd and I.L. Finner. These are the references for this topic. Next topic, next class, we will discuss about electrophilic substitution reaction and different reactions of benzene. Thank you.